Hello, welcome back. We've spent the last several videos writing code using Boto 3 to interact with AWS programmatically. And in the next few videos, we're going to look at how we can robustly test code that we write using Boto 3. But before we do that, I think now is a good time to introduce the course project that we're going to be developing, because it's going to influence the direction we take as we write our unit tests. Okay, our course project is going to be to develop a REST API and deploy it to AWS and then set it up with observability. So that's monitor and alerting and generally a good troubleshooting strategy that we can follow when things go bad in production. Why are we writing a REST API for our course project? Well, the idea of this course is that it can take a person who is an intermediate Python developer and help them become an intermediate cloud engineer. And REST APIs are core to most kinds of architectures that you would want to deploy to the cloud. So commonly, if you're building something that's going to be deployed on the cloud, it's either going to be a REST API or involve REST API. So it's good to get exposure to understand how these things work. There are other kinds of services you can deploy that aren't REST APIs, like batch jobs. And in a lot of ways, those can be easier to write and operate than a REST API. So I think a REST API is complex enough that it will allow us to learn most of the concepts that you would need to run any software in the cloud, which will be instructive and helpful for you when you want to go write other kinds of applications. So if you want to write a website, it's probably going to need a backend REST API. Or if you want to write a Discord chatbot, or a service on a team within your company that exposes data to other teams, or a target to catch the outputs of a webhook, like if you're doing complex operations with something like a payments processor like Stripe. Or if you want to deploy a machine learning model that does inference real time, like ChatGPT. All of these things are use cases for REST APIs. In this course, I want to help you learn advanced patterns for designing a REST API that's easy to run and monitor and also scales well. And so I'll give you the backstory of this app that we're going to build, which I call Serverless Fast API. Every position that I've had professionally where I've written Python, I've always developed at least a few REST APIs. I started writing APIs with a framework called Flask and eventually moved to Fast API, which is what we're using for this project. And over time, I slowly picked up patterns here and there to avoid problems that I would run into that would either slow me down developing APIs or make it hard to run those APIs in production. And I found myself in that same position a little over a year ago, where the data scientists where I worked wanted a standard template that they could follow when they built REST APIs that we could use to serve our machine learning inferences in. And so given that this was something that I had been studying personally and professionally for several years, I decided to make a template that compiled into one place all the practices that I had learned. And so about a year and a half ago, I created this Serverless Fast API project, which was meant to be a reference project that had all these best practices. And then I offered up this template to where I work now. And since that time, we've created almost 100 REST APIs that we've deployed to AWS using a modified version of this template. Now, a lot of those were prototypes, and so they didn't stick and they have been deprecated. But some of them have scaled really highly. And in fact, even recently, one of these REST APIs is doing 2 to 4 million requests every day. And I should say that REST API that scaled so highly is being deployed on containers, and the way that we're going to deploy this REST API in this course is going to be on serverless Lambda functions, but certainly serverless Lambda functions can scale massively. And in fact, I would say that if you have an API written with Fast API, you should start by deploying it in a serverless fashion on AWS Lambda or something like it, because you only get billed per request when you do that. And so when you first launch a REST API, if you have limited usage, you'll spend a lot less money if you deploy it serverlessly. And this template lends itself very nicely to be deployed on a REST API, but also if or when you get to the point that you want to move this to containers, when you have more predictable traffic coming to your API, this template can also be ported to running on Docker containers with no code changes. And so whether you're working on a prototype and or a hobby project or something for work, whatever scale or budget you have, you can use this reference API that we're going to be building in this course to quickly spin up and deploy a REST API that meets your needs for whatever you're doing. Okay, so what exactly is this REST API? Well, it's basically a file management API. We can use this API to read and write and delete files from some sort of file storage. And I'm intentionally avoiding saying reading and writing files to an S3 bucket, even though that's what it does. And the reason why is because this REST API is supposed to be an interface that abstracts interactions with file storage. so that if you wanted to, you could swap out the underlying file storage for a different file storing solution. Or in other words, this API is designed to hide the underlying implementation of how the endpoints work. Good REST APIs maintain something called an API contract, and that is basically the set of endpoints that your API has. So you can see right here we have 4 endpoints. And it is the combination of inputs and outputs that those endpoints receive and return. One of the most important concepts for writing a REST API that other people want to use is that you have a very clearly defined contract and that you stick to that contract over time. And if you ever need to break that contract, like if you needed to remove one of these endpoints that were here, or if you needed to take away one of the parameters that one of these endpoints takes, you would need to communicate that to your users and potentially support an older version of your API until some sort of end-of-life period where you finally get all your users onto a new version. So doing breaking changes of a contract can be a huge pain from a development standpoint. And so it's really important that you design your contracts well so that you give yourself the freedom to make as big of changes possible behind the scenes in the implementation details such that you can keep the contract, or in other words, the interface that your users interact with, unchanged. Or at least unbroken, because as we'll see, additive changes like adding new endpoints don't interrupt user service. A lot of the discussion that we're going to have in the coming videos where we develop this fast API app will revolve around how we can hide the implementation details and maintain a good contract. Or in other words, how we can maintain a good abstraction over the endpoints of our API and the underlying implementation details. And this concept of abstraction is the reason I wanted to have this video before we go into testing. Okay, so in the coming videos immediately after this one, what I'd like us to do is write a few functions that use the Boto3 library to do operations against files in S3, roughly the same way that these endpoints would do. And then in the next module, we're going to build a fast API app that wrap those CRUD functions that we write with endpoints. And then we can talk more about API design at that point. So how exactly does this API work? This API is pointed at a single S3 bucket, and it has endpoints for reading and writing files. So for example, I have an endpoint for listing files. I'll try out this endpoint, and I'm not going to specify a directory path, and I'm going to hit execute. This is going to do is list all of the files in the root of the abstracted files directory that we have. And right now my bucket's empty, and so there are no files in it. But I could go to the post files endpoint, and I could define a path like folder/file.txt, and then set some content. Hello, everyone. And execute. And this would create a file in our bucket at this path, and then if I were to run files again, it would list that file. There's also facilities for deleting files and getting the contents of a file. And as I'm showing you all these endpoints, you can probably imagine in your mind code that we wrote not very long ago with Boto3 that can do all these operations against an S3 bucket. And that's good. It's good that the reading and writing of files is going to be easy because that way we'll be able to focus on testing and the design of our app. Later on, we'll also implement OpenAI, and we'll sign up for OpenAI, and we'll get an OpenAI API token, and we'll use that to be able to prompt OpenAI and generate contents of a text file. And that use case will be very instructive as to how we can manage secrets properly and generally not go overboard with our cost. And also setting up a distributed system where we have this app that reaches out to the S3 service, but it also reaches out to the OpenAI service, and so we have multiple moving parts. And so we'll cover a lot of strategies, talking about how to handle that well. Okay, so this is what the course project is going to be. In the next few units, we're going to write the underlying functions that use Boto3 that are going to power these endpoints, and then we're going to test those. And once we have these functions, then we'll move on to the next unit where we actually start authoring this fast API app and talking about design principles. Okay, thanks for watching this. I'll see you in the next video.